It's a beautiful day again to teach you guys on 321 exams. And with all pleasures, I will tell you, welcome to 321 exams. Hope you guys are having a lovely time. Yes, now let's proceed. Now today we are going to talk about a very, very interesting topic, which is what? Kinetic theory of matter and gas laws. Now we're going to talk about gas laws and kinetic theory of matter. On our outline today, we're going to talk about an outline of the kinetic theory of matter, melting, vaporization, and the reverse processes. We're going to talk about melting and boiling. Melting and boiling explained in terms of molecular motion and Brownian movement, the laws of Boyle, Charles Graham, and Dalton, combined gas law, molecular volume, and atomicity of what? Gases. We're going to talk about all this today, and it's going to be fun. First of all, let's talk about the kinetic theory of matter. Now, matter is composed of tiny particles such as atoms, such as molecules and ions. And this theory states that these particles are continually moving and so possesses what? Kinetic what? Energy. What matter is made up of? It's moving continuously and it possesses what? Kinetic what? Energy. Let's push forward. Now let's talk about the states of this matter. As we know, matter is made up of the solid, the liquid, and the what? Gaseous state. Now we're going to start first of all. Remember, we are following, or we are aligning our projects with your syllabus in JAMB. So let's talk about the solid state. Now, atoms, molecules, and ions in solids are very closely packed and held firmly by the force of what? Cohesion. Solids are firmly packed. There is a bond that holds solid, and this bond exists in, and this bond is talking about the force of cohesion, and it exists in electrovalent compounds. It exists in covalent compound, metallic compounds, and now all these compounds, now they possess this bond like covalent bond, electrovalent bond, even weak van der Waals bonds. Now these bonds are the forces of cohesion that binds them together. Now let's talk about the properties of these solids. I'm going to give you some properties of these solids that will help you in your exams. Now, one, as you know, they are held, like what we said before, they are held firmly by what? Forces of cohesion. Two, the strength of these forces of cohesion in solids, are you telling me, are you getting me? It depends on the compounds. It depends on the bonds. If it's electrovalent, if it's covalent, if it's metallic or van der Waals. Now, as we know, covalent bonding is the strongest. So the force of cohesion in covalent bonding is very, very high. So there's the restriction is very, very high. So it's highly restricted. Now, next is that they have restricted movement. They have restricted what? Movement. Now, as I say, the strength of this force of cohesion depends on the bond that forms the crystal structure or the crystal lattice. So I have, like I explained, covalent bonds, the force of cohesion is very, very strong. I get it, is very, very strong. So it depends on the what bond, the type of bond. And because of the force of cohesion and the in the bonds, I get me, they don't have restriction. They're not they have very high restriction rather. They have very high restriction. They don't just move freely. They are restricted. Are you with me? Now that is the second properties. Let's go to the third properties. Let's go to the third properties. They can only vibrate, and rotate. Now, because of there is no restriction in their movements, I get me, they are held in a fixed position. They are held in a fixed position. And since they are held in a fixed position, they can only vibrate. They can, you know, when something is vibrating, like electric shock, you imagine just with electric your body, just that's what they can only vibrate and they can rotate, but they cannot translate. So I'll put number 4, they cannot translate. They cannot what? Translate. Now, another property is that solids have a definite shape. They have a definite shape and volumes. Are you getting me? Another property of solid is that it is very, very difficult to what? Compress. You can't just compress solid. So 6, they are difficult to compress. Good. Example. Let's also do another example. Let me give you a diagram to show what you're talking about. Give a diagram. For example, if I have this, now let's assume this is solids that are packed. Are you getting me? Now, if you check it, it has a definite shape. It is fixed. They can't just move. There is restriction in their movements in and out. There is restriction. There's restriction in their movements in and out. So it's fixed. It's packed together. Are you with me? It is packed. So it doesn't need a container to give it a shape. It doesn't need a container. Yes, it doesn't need a medium to give it a shape. They have their shape. I get me, and they have its what? It have its what? Volumes. So this explains what solid state. Now let's go to liquid particles. Let's go to liquid what? Particles. The particles in the liquid state have more kinetic energy and are slightly further apart than those in solid. Now solid, they don't really have kinetic. When you talk about kinetic energy, you're talking about the energy that encourages these particles to move, energy in motion. I get me. So liquid states have more kinetic energy than solid states. Solid states have very less kinetic energy. I get me. So and they are slightly further apart than those in solid states. So liquid states have more freedom of movement. They are not restricted. I get me. They are not restricted like the solid states. Now let us also give properties of liquid states. Then we will continue explaining more on liquid states. Let's go to properties. Properties of liquid states. Are you with me? Number one, like we say, they are further apart. Are further apart than in solid state. Number two, they have more kinetic. They have more kinetic energy. I've explained that to you. Number three, they are no longer, they are not held in a fixed, held in a fixed position. Held in a fixed position. Number four, it's not fixed like solid state. They are held like solid state. They are held in a fixed position and their movement is restricted. But this, they are not held in a fixed position, so they have lesser restrictions. Number four, they can slide about randomly or irregularly. So anyhow you want to put it. Number five, they are held under the influence of force of cohesion. Now they are held under the influence of force of cohesion, but it's not as strong. The bond, the force of cohesion in liquid is not as strong as in solids. Are you with me? Solids have stronger forces of cohesion or cohesive forces than what? The liquid. Now let's talk about number 6 again. Their movement is less restricted than solid states. I've explained that before. Next, number 7. They have a fixed volume. Now, liquids have a fixed volume. Now, the volume of liquid actually take it's fixed compared to what? Solid. Are you with me? Now, number 8, they don't have a definite shape. Now, liquids don't have a definite shape. Their shape, you can't say this is the shape of a liquid. Do you know why? Because they take the shape of the container or the medium that the liquid is being poured into or the liquid is in. Are you getting me? So they don't have a specific what? Shape. Now, example, if I have a container like this, I have a container like this, and I have liquid particles packed in them. Now you can see Now if you notice something, you see that it's not packed. It's not packed like solid state. Like what we have in solid state, there is freedom. There is freedom of movements among them. So it's not really packed like the way it was in solid state. So it's not, the restriction is less. I get me, and the movement is more. telling you that it has more kinetic what energy than what the solid what state. So if you check, you see that liquid are put inside a container. It's this container that gives it its shape. Are you with me? Thank you very much.